Okay, so basically, what we're going to do this afternoon is just going through one of a previous assignment. So about 2 or 3 years ago, one of the first assignments, and just nearly preparing you for your first assignment that is is due very shortly, both for the 1510 and the 1610 guys. So basically just and I'll what I will do tonight, I'll also share the presentation with you on the WhatsApp group. So if you just want to send me a WhatsApp again, um, please do so, so that I can add you to the group. But I will send a WhatsApp, or I'll send the presentation to a WhatsApp group that you have that as well. Um, and obviously the recordings you will also receive. Okay. So so basically what I just want to go through is some of the questions, practice questions for assignment one. So it's basically looking at chapters 1 to 3. Um, and and this is a combination of some of the theory questions that might be in there. Um, there's a combination of tables that are in there. There's a combination of box and whisker, or box plot. So basically, it's just an example of one of the previous assignments. Okay, so the first question is, which of the following statements is incorrect? And again, I think the one thing that is very important with with your assignments and in the exam, just be very careful which words they use. So, which one of the following statements is incorrect regards to a statistic? Okay, so if you look at a statistic, and that reminds me, I will also send you summaries of chapter 1 to 3 um, in the WhatsApp group as well. That you can have it with you while you're doing the assignment. So let's look at what goes with a statistic, and then obviously the one that is incorrect. So when I see the statistic, I nearly always say, well, if I have a statistic, I have something to do with a sample. So let's see, a statistic is an estimate of a population parameter. Hmm. Okay. A statistic represents a property of a population and not that of a sample. So this one is interesting because the statistics represents a property of a population and not of a sample. So that one is definitely incorrect. A statistic is a summary measurement calculated for a sample. That is correct. A sample standard deviation is a statistic. That is correct. A sample mean is a statistic. That is correct. So let's just look. A statistic is an estimate of a population parameter. Okay, so population parameter. So if you look at your study guide, you will also see um, that is correct. So it's statistic will be an estimate of a population parameter. Okay, so that one is also correct. So the one that was incorrect is a statistic represents a property of a population and not a sample, but it actually does represent a property of a sample. Okay, so the first one nearly looks at study unit 1, and it asks you to nearly identify between the sample and population, and then around that, if there is anything else, a parameter or statistic or whatever goes with that. Okay, so that's nearly the first one that they can ask you out of study unit 1. Then the next one that they can ask you out of study unit 1 is nearly to say things about the variables. So they can ask you about quantitative, qualitative. They can ask you about categorical, numerical, continuous, discrete. So there's a few things that they can ask you around the variables, and normally they will ask you one or two questions around that. It might now be that in your assignment it might be a bit more, but in total, when we get to the end of the year and we get to your exam in the end of the year, it will also be basically 2 questions on study unit 1. So let's look at this one. Which one of the following statements is again incorrect with regard to variables? Okay, so a quantitative variable takes on values with equal units, numeric values that indicate how much or how many. What would you guys say, correct or incorrect? So quantitative looks at quantity. So quantity looks definitely at numeric values that indicate how much or how many. So that is definitely correct. So we need to go to the next one. Variables can be classified as categorical or numeric. What would you say on that one? Okay, classified categorical, numeric. That is also correct. So the categorical can also be qualitative. Numeric is quantitative, so it's definitely also correct. Quantitative continuous variable results from counting attributes of an element. So what do you guys think about this one? Quantitative continuous variable results from counting attributes of an element. Yes. Yes. Okay, so let's look at, I'm also wondering about that one. Because we're continuous and we're counting. So that for me is nearly what I'm also thinking. So yeah, and I think you're right, but let's just look at the other two. Numerical variables can either be discrete or continuous. That we know is correct. And then Qualitative variables uses labels or names to describe attributes. So qualitative is also correct. So Ian, you're right with a continuous and for counting, because counting is 1 to 3, but when it's continuous, it can be 1.6 or 1.7 or 1.8 or anything else. Yes, you have a question.
Because I also use there where it says attributes of an element. To say attributes, it means it's a quality. So it'll be like red hair or brown hair.
Yes,
So
yes,
it will be qualitative, not quantitative.
yes. So it describes something about or your hair or your eyes or where you stay or what you drive. So that is why it is qualitative. Perfect. That is the reason. So and I think what is the nice thing is it describes the attribute. And that nearly also need to give it away that it is qualitative. Perfect. Okay, more questions on this. And I think these are the things that is important nearly because it's just like these small words that can make it correct or incorrect in a sense. So again, very important to read carefully these questions, especially when it comes to the definitions on um, types of questions, because that is nearly where they want to catch you out, because it is open book. So they're not really going to give you always just a straightforward a sample parameter. A sample statistic is this, a population parameter is this. So they would nearly combine it into different ways to ask you. Okay, any other questions? Jens, do you still have a question, or is that just an old hand from a question that you've asked? Ah, cool. Okay. Okay, awesome. So one way that they can ask for questions is this type, but they can also ask the variables on a type of scale. So we know we've done the scale, so scale of measurement. Um, which one of the following statements again incorrect with regard to variables and their scale of measurements? Um, so the first one, a nominal scale of measurement is the weakest form, while a ratio scale is the strongest form of measurement. Sure, this is interesting, the wording that they use. I think it is somewhere in the textbook. I will just get you a page page reference for this, um, because it is somewhere in the textbook. I know I have it somewhere. Um, but basically, as you go from nominal, ordinal, up until nearly ratio or interval, will be your top scale. So the weakest will be your bottom one, and your strongest will be nearly your interval or ratio one. So but I will get a page reference for you on that. And I will even, I can still see the table in my head, so I will also send that to the group, um, that picture of what is in the book. If you guys don't have the book, I will definitely just take a pic of that and send it to you. So a nominal scale of measurement is the weakest form, while ratio scale is the strongest form of measurement. That is correct. So nominal basically doesn't give you any direction, where ratio will nearly tell you it is. So a ratio of 2 to 1, so you know that it's twice as big, where in nominal there is actually um, no form, or it's the weakest form. Then the next one, the mean and the median cannot be determined for a nominal scale of measurement. Okay, so what is a nominal scale of measurement again? So nominal scale can be anything, say one nominal scale can be what cell phone provider you use. So I can have MTN, you can have Vodacom. I can't determine a mean or a median on that data. Um, I can only determine a mean and median on data that I can count. Um, so I cannot determine a mean and the median on nominal data. So the mean and the median cannot be determined is also correct. Quantitative continuous variables result from measuring attributes of an element. Okay, so quantitative continuous variables measuring attributes of an element. Wasn't it nearly the same? Qualitative variables uses now to describe attributes. Okay. So quantitative continuous variables result from measuring attributes of an element. What would you say on that one? That should actually be wrong. Do you agree? Yeah, it was qualitative variables to describe attributes of elements, which was correct. Quantitative variables results from measuring attributes of an element. Now that one is incorrect. Do you agree with me? Okay. Ordinal scale of measurement is higher level of measurement than interval. So that one is also going to be wrong. Nominal, ordinal, then it's going to be interval. And then it is going to be ratio. So that one is actually also incorrect. So again, if you pick up a question that you feel is something like this, let me know. Um, it's you can, in that instance, take a picture for me as well, and send it to me. I know they tell you on the while you're doing it that you should not, But if you really feel like in this instance that there is a mistake in the question, by all means, let me know, and I can always refer that to back to the lecturer to say, but um, is there something wrong with that question? Then what they will do when they mark it, or they will adjust your marks or something like that. So just if you pick up something like that in when you do your assignments, please let me know. And if it is when you do the assignment the first time, I know you can get up to 3 times that you can do the assignments. Um, so if you spot it in the first time already, let me know, because the possibility is that when you do it the second time, there might be in the same question again an error. Okay, and then quantitative discrete variables result from counting. So we know discrete counting attributes. So that one is correct. Okay, so here we actually had two that was wrong, which is not supposed to be like that. Okay, but I will also get you the page reference in the book. It's not in the study guide. It is in the textbook, but again, I'll take a pic of that for you and send it on. Okay, so that was questions on quantitative, qualitative. So what they now add to that nearly is to say, okay, but there's still types of variables, but now we're looking at if you understand the difference within quantitative and within qualitative. So they basically want to see if you can understand those lower levels of the variables. So a majority of rural schools in South Africa, in the Eastern Cape, KZN, and Limpopo, Department of Basic Education requires your assistance in gathering some of the information. Which one of the following statements is incorrect with regard of type of variables? Okay, so the age at which learners first enroll at school is a quantitative continuous variable. True or false? And you can even just type in the chat as well. What would you have said if this was the age of which learners first enroll at school is a quantitative continuous variable? Okay, so it is true. So and let's see why it is continuous. So when I enrolled my kid and when you enroll your child, they will probably not be the same age. If it was the age in years, then it's different. Then we're dealing with discrete. Okay, so if I add it in years or in months or something like that, then it becomes discrete. But if they just tell you the age, then I don't, my child will probably say 6 years 4 months, 3 days, 2 minutes, or something like that. So, unless I tell him in years when the discrete will come out. So very important again how they phrase it and what they add to it. Okay, the travel time from the learner's home to school is a quantitative continuous variable. Exactly the same, because my travel time to school, your travel time to school will be different. If again it was said the travel time in minutes or the travel time in hours, then we would say no, but it is discrete again, because then it will be 100 minutes or so again, if we add nearly the measurement to that, then it becomes discrete. Otherwise, it stay continuous. So when you add the measurement to the question, then it will become discrete. Like the number of schools requiring learner transport is a quantitative discrete variable. True. Okay, so the number of, then it becomes discrete. Whether or not a school is classified as a special needs school is qualitative nominal variable. Yes or no? As a qualitative means that it's not a number. We're working with words. Nominal tells me there's no rank. It's just so it will be nominal because it's a yes or no. Okay, there's a question. Please ask.
I just want to say, it can only be yes or no.
Precisely. Can either be, it can just be yes or no. So being yes or no, it's nominal. It's the same with having red hair, yes or no. Having blue eyes, yes or no. So it's a qualitative variable, and then it is nominal. If there was something, okay, so let's look at the next one. The size of the bus that transport the kids are classified as small, medium, and large. So yes, it is qualitative, but is it normal? Oh, nominal, sorry. So it is qualitative. Is it nominal? Is it just words, or is there meaning in that, or is there order in that? So what we have here is we've got a small bus, we've got a bus that is bigger, and then we've got a really large bus. So this tells me that there is order in the size of the bus, which makes it ordinal and not nominal. So that is nearly the difference between D and E. D is a yes or no answer, but E is actually, is it small, medium, large? So there's actually order in that, and sometimes that is very tricky to see it in the question. So I think that is also very important in this instance. Okay, so that is I think when I go to the next one, that is the questions around variables. So this was basically study unit 1 that we've done up until now. Um, so you can nearly see the type of questions that you guys will also get is a combination of things. So it will not just be that they will give you a statement and then say, is this ordinal, is this nominal, is this, it will nearly be these kind of combinations that they will give to you. Okay, so let's then go to look at some of the questions that was asked around um, around study unit 2. But now this is so median was nearly covered in study unit 3 as well. So now look at this one, and this is nearly a combination now of study unit 1, 2, and 3. So this is again not a straightforward question. So let's look at what they give us, and then let's determine if we can do it. So some personal and school related information was collected on learners. Variables 1 to 5 below shows what's collected. Then we need to say for each variable, is it possible to determine the median? Okay, so they nearly now have looked at these, and now you need to say, can we determine a median out of it? So let's look at the first one, the progress at school, i.e., is it satisfactory or not? Can we get a median for something like that? So again, it's nearly a yes or a no setup. Satisfactory, yes. Not satisfactory, no. So can one get a median for that?
No.
No. Okay. So before I go to the next, I nearly look at, okay, so which one? So there's a 1 in it. So if I need to guess, I'm not going to guess option 1 or that one. Then I look at, is it possible to determine, it is possible to determine the median for all variables. So we already said, no, it's not for, there's another one that I can, one, okay, so that already I can also take away. Only one, no, it's also not. So by actually just looking at that, I already now know that E must be my answer. But let's look at the other options as well. Sex assigned at birth, i.e. female, intersex, or male. Very similar to satisfactory and not satisfactory. Um, so again, we can't get a median for that. A list of subjects enrolled for. If a question was number of subjects, okay, that's the next one, then yes, but the list of subjects, so you can be enrolled for maths, English, science, or whatever. You can't determine a median for that. But you can determine the number of subjects that are enrolled for. So if most students are, so if you can enroll for, say, 9 subjects, you can determine a median in the class or not. So definitely um, number 4 is correct. And then emotional quotient or IQ, so EQ or IQ scores, um, that is a number. So for EQ and IQ, because it is a score, again, you can determine the median. So when something is a number, you can determine the median. If it is not, so if it is a qualitative variable, you can't determine a median for that. So this was study unit 1 and 3 combined, where all the others were nearly just looking at study unit 1. This was a study unit 1 and 3 that was combined in this one. Okay, hope everybody is okay with it. So please ask if there's anything else. Um, okay, let's go on to the next one. So I don't think we'll use all of our 2 hours tonight, but I think this is just so that you can get a good nearly practice in of what might be in your assignment 1. Okay, so which of the following statements is incorrect with regard to tabular methods for summarizing data? Okay, so again, a lot of definitions and things that we're going to throw in here. It is nearly on anything that you could have looked at in study unit 2. So again, any way that you could have summarized data into a histogram, pie chart, if you looked at cross tables, if you looked at frequency tables, it could be anything of that. So let's see what they ask. A percentage is equal to the relative frequency um, multiplied by 100. Okay, so when we look at at the table, we look at frequency, we look at relative frequency. So we would say the frequency is say 5, 4, and say there was only these two, and it was total 9. A relative frequency then is 5 divided by 9, which will give us a number of, oh, I'm gonna now, let me get the right number. Okay, 0.56. And then if we want to work out the percentage, it is equal to the relative frequency times 100, so that we can get to 56. Yeah, 56%. Okay, so just again, when I read it, it looks wrong, but then if you go, okay, what is frequency? What is relative frequency? Okay, so if I multiply my relative frequency by 100, then it is actually a percentage that I get. So it is correct. I am unfortunately looking for the incorrect one. Okay, so next one that they ask us, cumulative frequency distributions are basically table methods suitable for summarizing quantitative data. Okay, yes or no? Okay, so when we look at quantitative data, it's something that we can count. So when we just look at frequency tables, it's great for that, but cumulative frequency is even better because then we can add and say how many will be up until certain points. So cumulative frequency distribution are suitable for summarizing quantitative data. They're not asking you if it's the best method or anything like that, because um, everybody will differ on that, but it is a suitable method to use. The next option is by asking us, when you're looking at frequency distribution, relative frequency distribution, and percentage frequency distribution, are they basically methods of summarizing both qualitative and quantitative? Okay, so now it becomes a bit more difficult. So what would you say in this instance? So let me quickly add a new slide. Okay, so when we have so they ask us for quantitative and for quali for qualitative. Okay, so for quant, it is, we can say something like this, and let's just use those. So if I'm working with quantitative, I can say, well, there was 4 numbers between 0 and 5. There was 5 numbers between 6 and 10. There's another 4 numbers, so in total there was 30 numbers. So that would have been my frequency. Then relative frequency would have been 4 divided by 13, 5 divided by 13, again 4 divided by 13. Then I will get a percentage of that. So I can multiply it out to get a percentage. I'm not going to do that now. And then I could have added cumulative as well, because the first one would have been 4 divided by 13. Then the cumulative will be 9 divided by 13, and then the last one would have been 13 divided by 13. So that is when I work with quantitative. So when I work with qualitative, so we had the small bus, we had the medium bus, and we had the large bus. So again, we could have said, okay, there's 4 kids driving in the medium bus or the small bus, 5 in that one, 4 in that one. So in total again, we've got 13, 13 kids. We can work out what the relative frequency is. We can work out what the percentage is. If I work out what the cumulative is, will it make sense? So here I was counting kids. Here I'm counting how many are driving in what type of bus. Does it make sense to have a cumulative frequency when it comes to qualitative variables? So not really, because it's not telling me anything really. Um, because at least here I could have said 10 or less kids. Here it doesn't really make sense to add quant or the cumulative, but I still have frequency, relative, and percentage that makes sense. Um, so if we go back to that question, we've got frequency, relative, and percentage, and we had it for both, and for both, it actually makes sense. So yes, we can use it in both qualitative and quantitative data to summarize the data. Okay. Um, to create a frequency distribution of qualitative data, we first need to define non-overlapping classes by determining the number of classes. So that's correct. Class width, that is correct. Class limits is correct. But it's not for qualitative, it's for quantitative. So they give you all the right words, but it is not for qualitative data, it is for quantitative data. So again, when you have quantitative data, you could see here I divided into classes, but I needed to, yes, needed to work out how many numbers were going to be, what the class width would have been, what the limits would have been. I just created something, but when you work with a set of quantitative data, yes, you need to do that. If you work with qualitative data, no, because you then just using what the qualitative variable was defined as. So again, everything else made perfectly sense. You also are looking for non-overlapping, but all of that is linked to quantitative and not qualitative. Okay, so we know that one is the incorrect one. Cross-tabulation are suitable for summarizing relationships between two variables. So I don't think we nearly looked at something like this, but when we get to study unit 4 and 5, when we start looking at probabilities, um, so a thing could have been that we're looking at eye color and hair color. So then you would have a summary of how many sits in each of that. So that's a cross tabulation, and that is definitely suitable when you look at two variables. Um, I I can't remember if that was even mentioned somewhere in the study guide, but it will probably have been in the textbook again. So, but that is also good that we've now done something like that. So that will also be correct. Okay, so here they nearly looked at different methods of summarizing the data, and they nearly asked some of the theory behind it instead of saying to you, here is the data set, let's analyze the data. So it is more, in this one, it was more about understanding how the data set is set together and what you're allowed and not allowed to do within, and a lot really on frequency tables. So that nearly then will give you the idea that the next question will be on a frequency table. So they nearly give you the theory first, and then they go into the frequency table itself. And remember that your assignment is, I call it linear, so that you can't go back. Um, so when you're done with question one, you go to question two, you can't go back to question one again. Um, so it would now have been nice when we talk about class width and those kind of things to nearly go back to say, was there anything else mentioned around it? But unfortunately, your assignment is that you are not allowed to go back to the previous question. Okay, so let's look at what they give us. They tell us this table is already cumulative. Um, so things that are missing here is obviously frequency, um, might be relative frequency, but let's look at what they want to ask us out of this. Okay, so they say it's a group of grade 7 learners. There's about 50 of them, and it this is how they are distributed according to distance, in kilometers from school. Okay, so then I give you a lot of options. So the percentage frequency of class 9 to 11 is 34. Okay, 9 to 11 cumulative is 17. So your cumulative frequency would have been 17 divided by 50, which would have given you, and then if you times 100, it would have given you a percentage, which is 34. Okay, so your cumulative frequency would have been 34, not just your normal percentage frequency. Okay, so that one is incorrect. Let's just check what it should have been. So if that is 4, how many would have been in 9 to 11? If a total was 17, this should actually be 13. So 13 would have been in 9 to 11. If that is 42 and it was 17, then 25 will be in 12 to 14. 48 minus 42 is 6, would have fallen into that. 50 minus 48, 2 would have, so that would have been your frequency numbers. So if I needed to work out the percentage of frequency for class 9 to 11, it would have been 13 divided by 50, which would have been 26 or 0.26, and then a percentage is times 100, which would have given me 26. Okay, so again, just be careful with what is frequency and what is cumulative frequency. So cumulative is always the sum of the previous one added to it. So the midpoint of class 6 to 8, 6 to 8. So what's in the middle of 6 to 8? 7. So that is correct. The relative frequency of class 18 to 20. 18 to 20. So we know the frequency is 2 divided by 50. So the relative frequency, the frequency is 2. The relative frequency is 2 divided by 50, which is 0.04, which is correct. If we needed to work out again the percentage, we would have multiplied it by 100 to give you 4%. The width for each class is free. Okay, so this is a bit difficult in a sense. One nearly wants to say 8 minus 2 to give you 2, or 11 minus 9 to give you 2, but it includes all values from 6 up until 8. So 6, 7, and 8. So there is actually 3 numbers involved there. So your width of it is 3. So what it includes is, so every number that is to do with 6, every number that is to do with 8, 7, every number that has to do with 8 as well. So if it was, and we will see in this data set, 6.2, 6. So it could have been 6.1 up until 8.9. So that is why we say that the class width is actually from 6 to 8, which gives you free data points. And then the frequency of class 15 to 17, 15 to 17, the frequency we looked at, and that was also, it was 6. Relative frequency would have been 6 divided by 50. If we wanted to say cumulative frequency, it would have been 48. Relative cumulative frequency would have been 48 divided by 50. And then relative cumulative frequency as a percentage then would have been the 48 divided by 50 times 100. That would have given you 96%. So again, around these frequencies, relative frequency, cumulative frequency, they can actually ask you a lot of things. And sometimes they give you a table that they give you frequency numbers. Sometimes they give you the table where it is cumulative frequency. I have not seen that they give you relative numbers, but that might also be that they give you relative frequency numbers or something like that. Then just remember it was something that was already divided. Okay, so, and what they really like to ask the frequency table. Um, I've seen it now in the last couple of years. It is always in one of the assignments or the first assignment, and there's always a question on it in the exam as well. And what they also then normally like is to to take this question a further, and then say, okay, but we're still looking at those data, but now we are looking at the individual data points. And now when we look at the individual data points, now suddenly we can ask more things. Um, so they're nearly going from study unit 2, that is a summary of the data, straight into study unit 3, um, with that same data set, but now we're looking at Q1s, Q2s, third quartiles. We're looking at ranges. We can even look at median mode, all the same set of data that they nearly ask you just more things on. So what I would do is when I get this um, set of data, when you start doing the if if you get this in the nearly realize that there will be more on it. And what I would then do is when we now need to work out Q1, Q2, Q3, write it down on a paper as you work it out. Because again, we're working with it here. Now you're going to the next section. It might be that you could have used that information then in the second set of data or the second question without needing to work it out again. So if I look at here, we did quarter one, quarter three, we would have done third quartile. Then the next set of questions, they ask you interquartile range. Now you don't want to now go back and calculate it again. So if it is on the paper that you've been working with, please keep that. If you want to put these numbers into Excel to work it out for you, you can do it as well. Um, it's just one of those things that I think you guys are being timed. So I'm gonna put it in Excel while we are actually chatting. And I will just then show it to you guys after I've done it. So I'm just putting all the data in, and then you can also use it as a source when you need to do it. But for the first one, we can nearly look at the data, and there's not a lot that we need to nearly calculate via Excel. But I saw there's also standard deviations and things that we need to work out. So yes, they will give you, if you have this set of data, they will give you enough information that you don't need to calculate it with your calculator. So you don't need to worry too much about that. So let me just quickly at putting in 13, so in row 3. So while you guys are, can you so far look at what the range is, what some of the other things would be as well? Then I will just now put up my spreadsheet that I've been typing in, and we can just see how we can look at the data together. And when we can nearly cover 3 questions in one, as long as I have. Okay, just want to check again. Okay, so I'm gonna bring my text over. Okay, so here is my set of data. Okay, so can you guys still see it? Just want to make sure that you can see the data in the table in Excel. So just give me a thumbs up if you can see it in Excel, and if I need to reshare. Okay, cool. Okay, so the first thing that they ask us is we need to nearly look at the position of first quartile. There's also a position that we need to work out there. There's a position that we need to work out there as well. So the position of Q1, the formula is n plus 1 divided by 4. And I like to write the 1 in front because we're looking at Q1 and we're looking at Q2. It's n plus 1 divided by 4, but times 2. And when we do Q3, it is 3 n plus 1 divided by 4. Okay, so that is how we work out the position for everyone. Okay, so we know that there's 50 kits, so n is 50. So we could have said 50 plus 1 divided by 4. So the position for Q1 is 12.75. Okay, which we in this course we need to round it off. Okay, so it is position 13. So again, that's the difference in Excel. It would also say 12.75, but what we can do is so we could have said, okay, we know that is, I'm going to put in there. Divided by 4. So that was my n. So whenever you now have a different, and we can do that as well, so that it is reflective of what will be in there. So if you change something here, to take that out, you only have 49, it will automatically change your value. And then we can just say think we're supposed to be a round up, but I'll rather just do it like that. So for Q1, we've got it as 13, which was fine with them as well. Position of Q2, so you can already see if Q1 was 13, the position of Q2 can't be 12 and a half. So let's work Q2 out. Let's put Q3. Okay, so it's 26 and not, and then let's just do that for, and then Q3 is 38. So Q3 position is, so that's correct. The position of Q2 is obviously wrong. It should be 26 and not 12 and a half. So at position 26, they actually gave us the answer and not the position. So they gave us what the answer should be. The value is 12.5, not the position. The position is 26. The second quartile is calculated with an average between 25 and 26, which is correct. So again, if we have rounded that off to, it would have been 25.5, which is in the middle of the two. So in the middle of the two, that is quartile 2. The other thing that you also need to remember, the median is actually the same as Q2. So they can talk about Q2 or they can talk about the median. It is exactly the same thing. Then option D, the range is 14. So if you take the range is the maximum minus minimum, so 20.2 minus 6.2 will be 14, but let's put in here range as well. Range is maximum of this set minus minimum of this set, and it is 14. So again, what we could have done as well is to say, so just that I nearly give you all the formulas that you can nearly use for this. So we could have done minimum, we could have done maximum as well, and then we could have also set range is equal to that minus that. Okay, so again, you can see, so let's rather do it that way, that you then have a range. If I ask you minimum or maximum, you have that as well. Okay, so for this set of data, the one that was incorrect is the position of the second quartile. Okay, so now luckily we have this set of data, because now the next set of questions, they're asking us again a few things. So, but what they also give us is the sum of all observations has been calculated for your convenience. and is equal to 626.6. Okay, so that is probably so that you can work out the mean, because there is no ways that they will ask you in an exam or in an assignment to add all of those numbers together to get the mean. There is just no way. So that is why they would give it to you. So let's work that out as well. So let's work out what is the average. Or let's first work out what is the sum of all of these. Okay, so the sum was 66, like they told us. We know there is 50, so the average is basically that sum divided by the 50. Another way to get the average is just to use the average function on all your data, and it will give you the same answer. Okay, so the average is 12.5. So there was the mean, the average was 12.5. Okay, so that one is at least easy with what they've given us to work out. They will never ask you to add all of those together to work out the mean. It will just not happen. Okay. The interquartile range. So luckily we had this. So we had where position 38. So if we need to work out interquartile range, we need to say Q3 minus Q1. So that is our interquartile range, but so it's 58 was for one. The other one was 13. So my value was 14, my value was 11. So 14 minus 11 will give you the 3. If we use, and this is the place where the Excel is different, because Excel will go to exactly that 12.75 and not the 13. So that is definitely the big difference in this one. So you could see that it actually, even though the number was what we are looking for is 11.0, it calculates it with that extra 0.75 that it should be. So Excel is actually calculating it correct, but it makes it very difficult to work it to actually work it out in the formula. So I'm just showing you guys this now, but I will actually take it out, because it does give you, in certain instances, it will give you not the same answer. So if you now looked at that, so round it off, it's fine. So if you work with rounded off numbers, it is actually fine, but then one needs to work with rounded off numbers to get to that. Okay. So we've done the interquartile range, we've done the mean, The median, they actually ask in the previous one. So the median, they ask what that it is in between 25 and 26. So between 12.5 and 12.5 is 12.5. We've also okay, so this why did I do this? Okay, so we have also seen um, that was the 12.5. So we could say what is the median? So the value of that, so the value of Q2, which is the median, is 12.5. Okay, so that we have. So let's see, there is no mode. So let's see if we can do a mode in here as well. So let's see, it should be able to pick up a mode unless there isn't one. Is there a mode? Yes, also 12.5. Okay, so, and let's look at it because, so mode is the number that appears the most. So that appears once, 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 once. So there was something that appears twice. Okay, once, once, once off. So there's again twice. There's again twice. Okay, 1, 2, 3, 4, 5, 6. So 12.5 appears 6 times. Okay, so that is a lot. 13 appeared 3 times. 2 times. There's one that's 3 times, 3 times, 2 times, 2 times. Okay, so one could also see, yes, it is 12.5 because it did appear 6 times, which is the mode. So in this instance, the median, the mode, and the mean is all the same number. So if media mode is all the same, we actually have something that is symmetrical. So the third or the last option will also be correct because the distribution of the distance from home to school is symmetrical. Yes, it is, because, and it's the only time that it is symmetrical is when your mean, median, and mode is exactly the same. Okay, and in this instance, it was 12.5, so it is spot on. Okay, so the next set of questions will now be on the same set of data, but now we go to, so we've done now central tendency. Now we go to the dispersion of data. So basically, with one set of data, they tested that where was it? That they tested that you can do frequencies. They tested that you can look at Q1, Q2, and Q3. They tested everything around central location or central tendency. And then they ask you the fourth one on dispersion. Again, they will not ask you to work out this without giving you more information. So here they tell us the sum of squared deviations around the mean is given as that. Which one of the following statements is incorrect with regards to the variance and standard deviation? Okay, so they give us that so that we need to work out the variance. So there is a formula in your book that tells you to work out the variance is that you take that sum that they now actually have given us, the 406.369, and you divide it by n if you want to do if it's a population, and if it is a sample, you take that same value, the 406.369, and you divide it by n minus 1. Okay, so that's the difference between if it's a population or a sample. In this instance, we know that we're working with a sample because they tell us we're working with a sample. So if you do that calculation, the 406.369 divided by 50, you will get option A. Okay, which is, wait. So let's first, the population variance is that. So let me first check if I'm not making sense. Divided by 50. $406.369 divided. What is going on with my calculator? So let's go to this. Okay. There's a variance of a population. So if it was population, it would have been 8.12. Okay. It is not 8.12. Okay, so that is incorrect, which is then where we stop. But if we need to work out, there's also variance of the sample. Which is 8.29. Variance of a sample, correct. And then to get your standard deviations, you can do two things. So, or you can say that square root, or you can also say standard deviation of the population, and again standard deviation of the sample. So if we look at, and let's just round it off a bit. So standard deviation, the population standard deviation, 2.851, correct. The sample standard deviation, 2.880, 2.880, correct. Okay, and then the variance is equal to the standard deviation squared, which is also correct. So we could have said that if I take the square root of that, it will give me the same answer. Okay, so I will share this with you so that if you get something like that, you can use it, because I think this is very handy. If you change one of it, everything else will change with it. So if you update it with the data that that you will need, um, you will be able to get the information. So I will definitely share that with you, that you can, and this is for assignment one. But as we go through all the year stuff, we will add to this. So this is study units 1 to 3, but we will add to this. So when we get to some of the other work, we'll just add to this to make it easier for you. Okay, so we've basically now have covered the mean, median, mode, standard deviation, variance. What they might do is, if you had a set of 5 variables, or 5 numbers, then they might not give you the standard or the sum of a squared deviation, or like in the previous one, the mean. But if you have this amount of information, they will definitely give you the information that you nearly need to work it out. They will not expect you working against time to now use your formulas to calculate this. It will just not happen. Okay, so a few more questions. Um, so one other thing that they love to ask, um, we there's not a lot of that in your study guide, but they love to ask coefficient of variation. Um, Coefficient of variation is calculated as your standard deviation, not divided by V, divided by your mean. Okay, so that is how your coefficient of variation is calculated. I even don't know if there is a coefficient of variation formula. We can just check for you, but else we will. Okay, so that is the 5 data points that I've given you. Let's see if it is. What would they have? Covariance, covariance, covariance. No, okay, so there's not a coefficient of variance, but that's fine. We know that coefficient of variance is the standard deviation divided by your mean. Standard divided by your mean. Your mean is just your average. Okay, what is wrong here? Let's quickly check. Okay, multiply by 100. Okay, so 4 comma. Let me just check where is. Okay, so there we have it as 4,82. Okay, so it is again much simpler when you work it out in Excel. I just want to check. So you can see there's for 107. That was your mean. Was where the 5 point, so your standard deviation was also in there. So as you work certain things out, there's nearly pointers and which can make it that you suddenly, oh, there's a number, it must be that. But two of that is actually in how you calculate it and not the final answer. So again, you have your standard deviation, you have your mean, your coefficient of variation is standard deviation divided by mean times 100. So I must just remember that we must say times 100 because it's always in a percentage. Okay, is there any other easier way to do it? Very difficult because you would have needed to, in this instance, if you needed to work out the standard deviation, it will take you some time, unless you have a calculator that you can put that information in to work out the standard deviation. Else again, very simple in Excel to work out the standard deviation on that. Okay, so then we come to the last two, and again, they love to ask this in the exam and in your assignment, and I think the next one I showed last week as well, nearly the box plot. But let's first look at the things around the definition of it. So a box plot is also called the 5 number summary. Okay, so what we have in that 5 number summary is you've got your maximum, you've got your minimum, you've got Q1, you've got Q3, and in the middle you've got your median or Q2. Okay, so not the coefficient of variation. Okay, so your 5 number summary, your box plot, they can call it box and whisker as well, is basically minimum, max, Q1, Q2, Q3. And that we have calculated nearly in a lot of information. So they give us now that information where we also looked at the coefficient of variation nearly. So it will be a small set of data that they give you, and then they ask you to put that in a representative box plot. Okay, so when I look at this, the first thing I will do is to say, okay, the minimum value is 115. So I'm not going to work out anything yet. I'm just going to check where is my minimum. Okay, minimum here 100, so it's not 115, can't be. Minimum here is 80, not 115, can't be. Minimum 115, minimum 100, can't be. 115, less than 80 even, can't be. 115, might be. 115 can't be. Okay, so we actually only have this one left, but let's look at this, a minimum, Q1, Q2, Q3, and max. There it goes again and come back. Okay, so minimum and your Q1 is exactly the same number, which is correct. Q2 seems like it is across 120, correct. Seems like that is just a bit higher, so we assume it's 125, and that also a bit higher at 150. So box plot E is the correct one. Now, this again happens in your questions, so be again very careful, because I nearly want to say E is the correct answer, but E represents box plot B. Okay, so we need to go and look at where we're actually talking about box plot E. Where we're talking about box plot E, so the correct answer was actually C. So I don't like it when they do this, because this is purely want to catch you out. It doesn't really reflect if you know what is happening here, if they do it this strange method. But that is unfortunately what they will do in your assignment as well. So just be careful, and if you got to this point, nearly just make sure that when you tick the right one, that is with it. Okay, so that nearly is an overview of a previous assignment, um, for assignment 1, that covers study units 1 to 3. So yeah, please send me, if you're not on the WhatsApp group yet, please send me a WhatsApp, so that I can add you, because I also want to send you summaries of the study units that I've created and other things as well. I will share it on the My UNISA links as well, but again, to get access to that, you need to log in via your student number. Else, if you are logged in as a guest, you will not be able to get to all of those things. So that is, I will post some of it there, but I also want to just share it where you will be able to get more of it. So if I can then share it onto WhatsApp or another way to you, I will want to do it that way. Okay, that is practice for assignment 1. Is there any questions from your side? Have anyone attempted one of the assignments yet or not? Still too afraid to go into one of the assignments? Um, okay, so I think 1510 might be open, and 1610 might not be open yet. So yeah, so just remember you have you can do it 3 times. So when it opens, do it, see what issues you have. If there is time, we can actually then next week also check in on 1 or 2 of the things that might be in it. There's yeah, so I think study unit, there's in, and I will try to see, there was something in last year that caught everybody out. I will go and look for it. Um, it is mentioned in this book, but not in the study guide, but it is in the book. So I will just go and look at it. It was something around um, levels. So instead of looking at it as a interquartile range, they mentioned something else. So I will just need to look at the study book to and I'll take a picture of it because there is a to work out that there's a different formula and um I also looked at it and I was like, phew, I was did I need to work out the interquartile range or did I need to work out something else? And then I looked at it and got it in the book and it's not in the study guide. So I just want to nearly take a pic of that for you guys as well, to share. So yeah, good luck for the guys that's waiting for it to open for 1510 that is already open. Yeah, let me know how it goes. Okay, and that is it for tonight, everyone. We'll again next time, hopefully, load shedding schedules changes that I'm not in the 6 to 8 time slot anymore because 2 hours of darkness so that we can make it a bit later. But until then, we'll probably keep it 5 to 7 um, un, until I get into a better load shedding time slot. Okay, thanks everyone. I'll also stop the recording. I will put the recording again